Hello and welcome to another one of Dee's ADD videos. Today we're going to be looking at the concept of magnetic fields. What are magnetic fields? If you remember, we discussed electric fields when discussing electric force. And analogous to the electric field lines, we have magnetic field lines that are vector representations of the magnetic fields. Okay? The more they are, the higher the field, the closer they are, the higher the magnetic fields. Now, unlike electric field lines, the magnetic field lines do not end. The reason why is that we don't have magnetic monopoles. Let's take a look at this magnet here. There's going to be a north and a south pole to the magnet. Even if you were to cut it in half, you would create new north and new south poles. And basically what would happen here is you would have magnetic field lines coming out of the North Pole, but then back into the South Pole, so they never end. Here is what we actually have going on here. We have magnetic field lines coming out of the North, coming back into the South. All right? These are the magnetic field lines that you're seeing now. And tangential to the field vectors, you're going to see the magnetic vector field lines. This is for a magnet. For a lot of the problems we do, though, we won't be looking at scenarios like this. So magnetic field lines do not represent the force. Remember, the Lorentz force, or the force experienced by a charged particle from a magnetic field, is going to be obtained by doing the cross product and the right-hand rule. So put your fingers into here, curl in the direction of the velocity. This is your right hand. And then your thumb should be pointing straight up. Okay? And if you don't remember that, go back and check out the magnetic force videos and example videos and practice problems. The key, more important than any video or tutorial, is to just try a bunch of these things until you get them right. All right? Now let's get to our wire. Again, the wire has a excess of electrons, so the electrons move down the conductor, but the conventional current goes to the left. So if I put my hands with my thumb, this is my right hand, going down where the current is, and then I curl my fingers, that should tell you where the magnetic field is. All right? So let's use the rules again. Put your thumb down the direction of conventional current. Then you're going to curl your fingers around the wire, and the fingers will tell you where the B field is at a point. So for instance, if we wanted to know above and below the wire where the magnetic field is, we would have these two scenarios. So my fingers would be pointing into the page above the wire, and then coming out of the page below the wire. All right? Try it for yourself. Make sure you agree with that. Thumb in direction of current, curl fingers, and once you curl your fingers, it'll tell you where the magnetic field is going. So in this case, it's going counterclockwise around the wire. All right? And that's basically it with magnetic field lines. We're going to start looking at flux next. So make sure you understand what a magnetic field line is and how it relates to the big picture. And then we're going to attempt to quantify magnetic flux, much in the same way we did electric flux. Okay, the field dot the area. So I hope I've clarified enough for you to practice these problems, and thank you and have a nice day.